In this video, continue over the equations that we already started solving. Now we want to decompose 9x divided by 2x plus 1 squared 1 minus x into partial fractions, and so write it here: 9x divided by 2 plus 1, 2x plus 1, 2x plus 1 squared, then 1 minus x. So we want to break this. So in the denominator we can see we have got, first on this one we have got two factors. So the first one is just 2x plus 1, and then the second one is 2x plus 1 squared. So this is a repeated linear factor. And then the third one, that's where we only have 1 minus x. Okay, so here on top we are going to put a, on top here we are going to put b, and then on top here we are going to put a c, because they are all linear factors. We don't have any quadratic factor. It's just that for this one it is a repeated linear factor. Now we are going to go on and merge these as single fractions. And so what is the lowest common denominator for everything? Well, the lowest common denominator is 2x plus 1 squared, then 1 minus x, because this into this, what are we going to have? We're going to remain with 2x plus 1 and also 1 minus x, and then what remains multiplied by the a, so we're going to have a 2x plus 1, then 1 minus x. Then this one into here, this is going to remain, and then multiply it by a b, so that will be b 1 minus x, and then plus this into this, we are going to have this as what remains, and so we're going to have c multiplied by 2x plus 1 to the power 2. So because we can say in the denominators we have got same number, so we're just going to equate the numerator. So 9x is going to be equal to a k. I can just go on and expand 2x by 1 there, that is going to be 2x, 2x by negative x, that will be negative 2x squared, and then 1 by 1, that is a 1, then 1 by negative x, that is a negative x, and then plus b times 1, that is just a b, then b times negative x, that will be negative bx, and then plus c. We can expand this one. Just get the first one, square it, that is going to be 4x squared, and then multiply 2 by this, so that is going to give us also 4x, and then get the 1, square it, that will just be a 1. So this is 9x is equal to, multiply now a with everything in this bracket, that will be 2ax minus 2a x squared, and then, well, before I could have even done that, I should have added something here. So 2x minus x, that will just give us x, so that will mean a times x, that will be ax, and then a times negative 2x squared, that will be negative 2a x squared, and then a times 1, that will be just a, and then you've got plus b minus bx plus c times 4x squared, that will be 4cx squared, c times 4x, that will be 4cx, then c times 1, that will be a c. Alright, and we can proceed putting like terms together then after this. So this will be 9x is equal to, those with a squared, we've got this one and this one. This is a 4c. I'm going to start with the 4c because it's positive 4c. Just writing the number in front, and then we've got negative 2a so negative 2a, and then I'll put x squared outside, and then plus, we go to those with only x. We've got a, we've got negative b, then we've got positive 4c, then I put x outside. Well, we can go to constants. Plus, we have got the first constant is a, and then b, and then a c there. Okay, now we know we don't have anything in x squared this side, and so that means the 4c minus 2a should be equated to 0 because we don't have anything with x squared this side. And then the a minus b plus 4c should also be equated, but this one, there is x there and there is x here, so that one should be equated to 9. But a plus b plus c, they should be equated to 0 because we don't have any constant this side. At this point, I can make a sub the formula here, so a is going to be equal to, okay, let me not make a in that one but in this one, so I'll say take 2a this side, that is going to be 2a is equal to 4c, divide by 2, so a is going to be equal to 2c. So where there is a, I'm going to put 2c, so here 2c minus b plus 4c is equal to 9. So 2c plus 4c, that is going to be 6c, then minus b, that is going to be equal to a 9. And then I can make b the sub the formula. I'll take b the other side and take 9 the other side. So b is going to be equal to 6c minus 9. Okay, and then I'll come here where there is, I'll put 2c, so it will be 2c plus b plus c is equal to 0. 2c plus c, that will be 3c plus b is equal to 0. So it will be b is equal to negative 2c. So I'm going to equate these two. So I'll say 6c minus 9 is equal to negative 2c. Taking 2c this side, that is going to give 8c, and that will be equal to, I'll take 9 this side, 9. So that means c is equal to 9 over 8. Alright, now after finding the value for c is equal to 9 over 8. And then to find the value for b, to be 6, where there is c, or I'm getting, I can use either this one or this one. So let me use this one, which is negative 2c, so to find the value for b. So b is equal to negative 2 times c, which is 9 over 8. And so 2 can go into there 4 times, so that b is going to be equal to negative 9 over 4. So let me keep it here. So b is equal to negative 9 over 4, and then c is equal to 9 over 8. Well, the next one we can find is a, and that's the one which is remaining to find. And for a, we know that a is 2c. A is equal to 2c, and so that is going to be equal to 2, where there is c we've already determined as 9 over 8. So that is going to give us 2, there is 1, 2, there is a 4, so that is just 9 over 4. Now that we have got all the values of a, b and c, we go on and substitute in there. So we say this is equal to, a is 9 over 4 divided by 2x plus 1, and then B is negative 9 over 4 divided by 2x plus 1 squared, and then C is 9 over 8 divided by 1 minus x. So I can bring what is in the denominators of the upper numbers into the denominator. So this becomes 9 divided by 4 2x plus 1, and then this becomes negative 9 divided by 4 2x plus 1 squared, and then plus 9 divided by 8 1 minus x. So we have expressed into partial fractions that one. Then let's consider this one. Given that A is that matrix, we want to find the inverse of that matrix. Well, when we want to find the inverse, the first thing that we want to find is the determinant. So the determinant of this matrix A, let's call it det A, is equal to, we get the first number here, that is 1. Okay, so if we remove the row and the column for this matrix which remains, we find its inverse. So 3 by 3, that's a 9, minus 2 by 6, which is a 12. Yes, so 3 by 3, 9 minus 12, and then we get this number which is here. We change its sign, so that to be a negative 1. If we cancel all the row and column, where negative 1 is going to remain with 1 1 6 3. We find the determinant 1 times 3, that is a 3, minus 1 times 6, that is a 6, so that is 3 minus 6. And then we get now this number which is there, positive 1. Cancel out the row and the column. Matrix which remains here, we find this determinant. So that is 1 times 2, which is a 2, minus 1 times 3, which is a 3, so that is 2 minus 3. So this will give us 9 minus 12, that is a negative 3, minus 3 minus 6, that is a negative 3, 2 minus 3, that is a negative 1. So this is negative 3 plus 3 minus 1. Okay, negative 3 and plus 3 cancels, so the determinant is just negative 1. Let me put it here, that A is equal to negative 1. So the next thing that we have to find is the adjoint of the matrix, and that is where the most of the process lies when we are finding the determinant, the inverse of a 3 by 3 matrix. So we're going to construct another matrix, a different one called B. We'll just name it anything. So for this matrix, what to do is we're going to get this number. If we cancel out the row and the column, the matrix which remains is this one. At the very point where 1 was, which we've cancelled out, we are going to put that matrix which remains, 3 2 6 3. So that is 3 2 6 3. Then we are going to go here, we cancel all the row and the column. The matrix which remains is 1 1 6 3. We are going to put where we removed the 1. So that is 1 1 6 3. And then at 1 we cancel out the row and the column, remain with 1 1 3 2. So that is 1 1 3 2. And then we are going to go to this number, cancel out the row and the column will remain, so we are remaining with 1 2 1 3. So we write it where we removed the 1, is here, 1 2 1 3. Then we go to 3, cancel out the row and the column, remain with 1 1 1 3. We are going to write it there. So that is 1 1 1 3. Then we go to this one here, cancel out the row and the column, remain with 1 1 1 2. So put it here, 1 1 1 2, and then the last one, the last column, okay, I mean the last row. If we remove that, going to remain with 1 3 1 6. So we put it here, 1 3 1 6, and then we come to this one, remove the row and the column, we remain with 1 1 1 6. So that is 1 1 1 6, and then the very last one here, we remove the row and the column, we remain with 1 1 1 3. So that will be 1 1 1 3. Okay, like that. So what we are going to do is we are going to multiply this matrix with a matrix of cofactors. This is just a matrix of signs having different signs. So here the sign is positive, negative, positive. Here negative, positive, negative. Here positive, negative, positive. So the sign just go on alternating. So let's proceed. And so this is going to give us, we find the determinant of these, or each of these matrices which are inside. 3 times 3, that is a 9. And then minus 2 times 6, that is a 12. Then we come here, 3 times 3, I mean 1 times 3, that is a 3, minus 1 times 6, that is a 6. And then the other one, 1 times 2, that is a 2, minus 1 times 3, that is a 3. Coming here, 1 times 3, that is a 3, minus 2 times 1, which is a 2. And then 1 times 3, that is a 3, minus 1 times 1, that is a 1. Then we come on this one, 1 times 2, that is a 2, minus a 1. In the last column here, multiply this, 1 by 6, that is a 6, minus 3 by a 1, that is a 3. Then 1 by 6 again, that is a 6, minus 1 by 1, which is a 1. And then 1 by 3, that is a 3, minus 1 by 1, that is a 1. Okay, so this is going to give us the matrix B, which is equal to 9 minus 12, that is a negative 3. And then 3 minus 6, that is a negative 3, but there is already a negative there, so it becomes positive 3. 2 minus 3, that is a negative 1. 3 minus 2, that is a negative 1, I mean a positive 1, but because of the negative there, it becomes negative 1. 3 minus 1, that is a 1. 2 minus 1, that is positive 1, but because of the negative, becomes negative 1. Then 6 minus 3, that is a 3. 6 minus 1, 5, times negative 1, negative 5. 3 minus 1, that is a positive 2. Now what we'll do is we're going to find the transpose of this matrix. The transpose of this matrix gives us the adjoint for the original matrix which started with. So we're going to say A adjoint of A is equal to the transpose of this matrix which you formed. That is going to be equal to, we swap the row for the column, so this becomes the column, swap for the column for the row, and opposite this will be negative 3, 3, negative 1, and then we've got the second one, negative 1, 1, okay, and then negative 1, and then the third one, that is 3, negative 5, and then a 2. I just noticed 3 minus 1 here is supposed to be a 2, so I wrote a 1, so this is a 2. So this is going to be the adjoint 3, negative 3, 3, 1, 1, 2, negative 1, and then 3, negative 5, and a 2. Okay, so that is our adjoint. Now to be able to find the inverse, how do we get to find the inverse of a matrix? So the inverse is simply determinant times adjoint. So A inverse is equal to 1 over determinant of A times the adjoint of A. So 1 over the determinant we found negative 1, so 1 over negative 1 is simply negative 1, then times the adjoint, which is negative 3, 3, negative 1, negative 1, 2, negative 1, and then 3, negative 5, 2. So going to multiply this negative with everything inside. So the first one, the sign becomes positive, positive 1, then negative 3, and then this will become negative 3, negative 2, positive 5, then this becomes positive 1, and then negative 2. So this is the inverse of the matrix A. Now the second one, hence or otherwise find x given that y is equal to ax. Now if y is equal to ax, we've been given y is 1, 2, 1, and that is equal to a. We know the matrix A is 1, 1, 1, 1, 3, 2, and 1, 6, 3, but we don't know the matrix X. Okay, so that is what we want to find. But how can we find this? Well, to remain with x alone, we need to multiply both sides by the inverse of this one, because if we multiply by the inverse, this one goes, and so if we multiply by the inverse, this one is going to go. We are going to remain with x alone, so I'll just write x, and then this side I'll just multiply this one by the inverse of the first matrix, because this matrix A, its inverse we've already found, that's the one here. So we'll just write 3, negative 3, 1, and then we've got 1, negative 2, 1, negative 3, 5, negative 2, and then we're multiplying by this matrix, which is 1, 2, 1. So we go on. X is going to be equal to, well, for us to multiply matrices, this times this, that will be a 3, this times this, that is going to be, okay, that is 1 times 2, which is simply a 2, and then negative 3 times negative 1, that is going to be a negative 3. And then we go again with this one down, negative 3 by that number there, they can't be seen now because I've written there. So we found 3 plus 2 minus 3, negative 3 by 1, that is a negative 3, write it there, negative 2 by 2, that is a negative 4, and then 5 by a 1, that is a positive 5, and then 1 by 1, that is a 1, plus 1 by 2, that is a 2, plus negative 2 by 1, that is a negative 2. And so the matrix X is going to be equal to so this and this cancel, so just remain with a 2. Negative 3 minus 4 plus 5, that is going to be a negative 2. Okay. And this cancel, so just remain with a 1. So this is the matrix X, which we have been asked to find.